Next topic is divergence of the vector point function. Let f vector be any continuous and differentiable vector point function, then I dot dou f vector by dou x plus j dot dou f vector by dou y plus k dot dou f vector by dou z is called the divergence of f vector, and it is written as del dot f or div f. That is del dot f vector equal to div f vector equal to I dot dou f vector by dou x plus j dot dou f vector by dou y plus k dot dou f vector by dou z, or simply I dou by dou x plus j dou by dou y plus k dou by dou z dot f vector is nothing but f1i plus f2j plus f3k, where f1, f2, f3 are the functions in x, y, z variables. That is f vector equal to, where f vector equal to f1i plus f2j plus f3k, or f1 of x comma y comma z into I plus f2 of x comma y comma z into j plus f3 of x comma y comma z into k. Simply we can say that the dot product in between of vector operator and vector point function is said to be the divergence of the vector. Okay, in the sum properties we have to remember, let it be note 1. Note 1 means that is the first formula, divergence of f vector plus or minus g vector is equal to div f vector plus or minus div g vector. Second one is a vector dot del of pi is equal to a vector dot I into dou pi by dou x plus a vector dot j into dou pi by dou y plus a vector dot k into dou pi by dou z. That is nothing, it is a scalar function. Third one is a vector dot del vector, that is the operator, into f vector. It is nothing but this is equal to sigma a vector dot I into dou f vector by dou x. These are the basic conditions for divergence of the vectors. But here one more thing, del dot f vector is never equal to f vector dot del. Why? Because in general a vector dot b vector equal to b vector dot a vector. But in the operation, both are not equal. Okay.
Yes, ma'am.
The solenoidal vector means a vector point function f vector is said to be solenoidal if div f vector is equal to 0, a vector point function f vector is said to be solenoidal if div f vector is equal to 0. Here, this equation, what is div f vector equal to 0? This equation is said to be continuous equation or the equation of continuity or conservation of mass. This equation is also called as the equation of continuity or conservation of mass. Okay, if we can find out the conservation of mass means from the relation of the solenoidal only we can calculate. Okay, next definition is the curl of a vector. Curl of a vector means let f vector be any continuous and differentiable vector point function any continuous and differentiable vector point function. Then the vector or the vector function defined by I cross dou f vector by dou x plus j cross dou f vector by dou y plus k cross dou f vector by dou z is called curl of f vector, and it is denoted by del cross f vector or curl f vector. That is nothing but curl f vector is equal to del cross f vector equal to sigma I cross dou f vector by dou x or the determinant of I, j, k, dou by dou x, dou by dou y, dou by dou z, f1, f2, f3. Here, where f vector equal to f1i plus f2j plus f3k. Here, f1, f2, f3 are the functions of the variables x, y, z. Simply, you can remember the curl is nothing but cross product in between of the operator and point function. Div f means dot product in between of the operator and vector point function. When we can take the dot product in between of vector and vector operator, that is nothing but the dot product in between of the two vectors is nothing but a scalar. The cross product in between of the two vectors is nothing but a vector. You remember that one.
Yes, ma'am.
Next definition is very, very important. That is irrotational. irrotational. A vector f vector is said to be an irrotational if del cross f vector equal to 0 or curl f vector equal to 0. This is nothing but then f vector is said to be the irrotational vector. Irrotational vector is also defined as any motion in which curl of the velocity vector is a null vector, that is curl v vector is equal to 0 vector, is said to be irrotational. Any motion in which curl of the velocity vector is null vector, that is nothing but curl of the velocity vector is null vector means del cross v vector or curl v vector is equal to 0 vector. Okay, then it is a null vector, that is nothing but del cross v vector equal to curl v vector equal to 0 vector is said to be irrotational. Okay. Next, in this, we can remember some definitions. How to find out the work done by a force. They will ask to find the work done by a force. Work done by a force. In this, which relation is interlinked with the curl and die? Here, f vector is irrotational, then there is always exist a scalar point function phi. That is nothing but f vector is nothing but grad pi. When it is f vector is said to be the irrotational. It is irrotational condition. When it satisfies the irrotational means then there exists a scalar function. That scalar function is pi. It satisfies the relation grad pi is equal to vector. Here pi is said to be the scalar potential of f vector. Scalar potential of f vector. Potential of f vector. That is nothing but we can prove that if they have given it is irrotational means to relate with the grad phi and check with the curl f vector. For that relation, if and only if there exists a scalar function phi. So that scalar function is said to be the work done by a force. Okay, that is the idea of the work done by a force. So we can here how to find out the scalar potential function means we can write it as note if f vector is irrotational, there will be always exists a scalar function phi of x comma y comma z such that f vector is equal to grad pi. This pi is called a scalar potential. A scalar potential of f vector. That is nothing but del cross f vector is equal to 0 if and only if there exists a scalar potential pi such that f vector equal to del pi or grad pi. It is also important. Conservative vector field is nothing but if f vector is a conservative vector field, then curl f vector is equal to 0. Then curl f vector equal to 0. When the formation of the conservative field means, let D be a set of the point in a plane, any plane, a vector field is capital F vector is the vector field. That vector is in the domain, that is a set of points in a plane. In that there exists some real function pi such that F vector is equal to del pi. So here pi is nothing but potential function. When the curl f vector or curl v vector or curl any vector is equal to 0, then that vector is associated with the scalar potential function, that is pi, and it satisfies the relation that vector conservative vector field is equal to del pi or grad pi. Okay, that is nothing but f is the conservative vector function, then d is the conservative vector field associated with the scalar function and the vector function. That is the definition. They will ask the conservative vector function. In such cases, we can recall this form. Laplacian
Engineering
operator.
or
Engineering only. Engineering or any
I see.
degree physics. Electronics
Electrical.
also. In the electrical circuits, they are using this Laplacian operator and Laplacian equation. Okay. It's a Laplacian operator is nothing but it is the del square. Del square is nothing but we know that del is the vector operator, that is I dou by dou x plus j dou by dou y plus k dou by dou z. Then this Laplacian operator can be applied on the scalar function. If we can find out the del dot del is nothing but I dot I equal to 1, that is nothing but dou square by dou x square plus dou square by dou y square plus dou square by dou z square. It is called the Laplacian operator. Laplacian operator. This operator can be applied on the scalar function, that is nothing but del dot del pi is equal to sigma I dot dou by dou x of I dou pi by dou x plus j dou pi by dou y plus k dou pi by dou z. It is equal to dou square pi by dou x square plus dou square pi by dou y square plus dou square pi by dou z square. It is nothing but del square pi. So this del square is an Laplacian operator. In this, how to find out this Laplacian operator means we know that del pi is nothing but del square pi is nothing but del dot del pi. Del dot means that is div, del pi is nothing but grad pi. Del square pi is equal to div grad pi. It is the first relation with the operator and div grad. The second one is if del square pi is equal to 0, then pi is said to satisfies the Laplace equation. Satisfy the Laplacian equation. Laplacian equation is nothing but dou square pi by dou x square plus dou square pi by dou y square dou square pi by dou z square. That is nothing but del square pi equal to 0 means dou square pi by dou x square plus dou square pi by dou y square plus dou square pi by dou z square is equal to 0. Okay. The third also, if del square pi is equal to 0, that is nothing but pi is a harmonic function. That is the harmonic function, and it is a constant function. Then the surface represented by pi is called potential surface. When it is equal to 0, the pi function is satisfies the Laplacian equation. That pi function is called as the harmonic function. And if pi of x comma y comma z is a constant function, it is a constant function, then the surface represented by pi represented by pi is called potential surface. These are related to the physics. Here, the harmonic wave functions and heat functions, those all are related to the partial derivatives. Why? Because if any wave function and heat functions are related to the two or more variables, so here time and surface, time and variables, that is the. So in that case, we use the some Laplacian equations. Okay.